Hey everybody, we are going to continue working with complex numbers, and we're going to start with multiplying like we did in the last video. So right here with number 10, we are multiplying 3i plus 5 times 3i minus 5, and we're going to use the box method again. So 3i on top plus 5, and then 3i minus 5 on the side. And then we're going to multiply row times column. So first box, top left corner, 3 times 3 is 9. I times I is not I squared. Then top right corner, positive 5 times 3 is 15. And then we have times an I. Bottom left corner, 3 times negative 5 is negative 15. And we have an I. And then bottom right corner, 5 times negative 5 is negative 25. Now, what's interesting about this one is that if you combine the like terms, when you multiply, notice in the middle we have positive 15i minus 15i. So these actually add up to 0. And so if we simplify what's in our box, we have 9i squared minus 25. But if you remember from the previous video, anytime you have an I squared, you always have to replace that with what it equals. So as a reminder, I squared is always negative 1 because what we know about I. So quick reminder on this. By definition, square root of negative 1 is your imaginary number I. So if you square that, that's where we get I squared equal to negative 1 from. So keep going, replace this a little bit further. We're going to say that 9 times negative 1 minus 25 is our answer. And then we will go a little bit more. Negative 9 minus 25 is negative 34. So this one is interesting. The imaginary parts of the complex numbers actually went away. So you can say that this is negative 34 plus 0i, or you can just say negative 34. And so this is not a coincidence. So the formatting of our original equation here, this expression that we were multiplying, because it was the conjugate, the terms were conjugates of each other. One had a plus sign, one had a minus sign, but other than that, they were the same. That's why those terms in the middle added up to 0. Here's why. So let's generalize this. So in general, if we have a plus bi times a minus bi, the two terms in the middle will always add up to 0. Let's verify. Top left corner, a times a squared. Top right corner, a times b, I'm going to write it as just ab, and then times an I. Bottom left corner, a times negative b, I'm going to write it as negative ab, and then we had an I there. Bottom right corner, negative b times positive b is negative b squared, and then I times I is I squared. So notice the same thing happened here. These two terms in the middle are like terms, and when you add them, you will get 0. And so we can simplify this answer, and we have a squared, and then notice what we have right there. We have a minus right here, minus b squared times I squared, but we're going to replace that I squared with what we know it equals. We know that I squared is always negative 1, so this is a squared plus b squared. All right, so this will always happen when you multiply one factor by its complex conjugate. So this is a complex number, a plus bi, and then this is its conjugate, a minus bi. So anytime you do that, you will get the two terms in the middle of your multiplication to add up to 0. So let's make a mention here. What do we notice about the products in the questions? Were there any imaginary numbers in your answers? Well, we just talked about it. No, and it's because we multiplied by a complex number and its conjugate. Okay, let's continue. Now we are going to do something a little bit different. We are going to rationalize the denominators for complex numbers. But if you recall from the past, we are technically dividing here. So whenever you're told to rationalize a denominator or rationalize something, you're basically trying to get rid of the radical. So this point, if you recall, just that I equals a radical. It equals square root of negative 1. So the problem here is that there's a radical in the denominator, so we need to get rid of it. We need to rationalize it. And the way we do that is multiply by the conjugate. Okay, so we technically are multiplying by the number 1 because we're going to multiply the top and bottom by the same thing, but we are choosing the number 1 in the form of the conjugate of the denominator over itself. So the denominator is 5 plus I, so the conjugate is 5 minus I. We multiply top and bottom by the same thing because this is technically 1 when we do that. And so then we just multiply it out from here. And what you'll notice is there will be only a real number on the bottom when we're done with this process. Okay, so from here, we are going to distribute on top because it's a 7 times a quantity. And we have to actually FOIL or use the box method on the bottom because it's a binomial times another binomial. So on top, we have 7 times 5, so 35. And then 7 times negative I, so negative 7I. On bottom, we are going to FOIL that out. Let me just get rid of this. Let's just FOIL this one now. We won't use the box this time. We'll just walk through it. So first times first is going to be 25. Outer times outer is going to be 5 times negative I, so that's negative 5I. Inner times inner, let me switch colors so it doesn't get so messy, is I times 5, so plus 5I. And then last times last is I times negative I, so that's negative I squared. Okay, so then that's our multiplication part. That part's done. Let's just start simplifying. So on top, there's really nothing we can do, so we're going to leave that as 35 minus 7I. On bottom, however, notice something, and we talked about this just a moment ago. Anytime you multiply a complex number by its conjugate, the terms in the middle of your FOIL process or multiplication process will add up to 0. So negative 5I plus 5I is 0. So those we don't even have to rewrite. So on bottom, we have 25 minus I squared. But also remember, anytime you see an I squared, it's always negative 1. So replace that. And so what we have is 35 minus 7I on top. On bottom, we have 25 plus. That becomes a plus 1, so 26 on bottom. And now we do not want to leave our answer like this, even though this is the correct answer. What we have to do is separate this. So you want the real parts to be separate from the imaginary. So this is 35 over 26 minus 7 over 26I. And this would be the official final answer for this one. We are going to rationalize the numerator this time. So whatever you were told to rationalize, that's what you're going to multiply by the conjugate of. So this time we are rationalizing the numerator. So we are going to multiply by 3 plus I, top and bottom, because that is the conjugate of our numerator. Okay, and then we are going to have to actually FOIL out both the top and bottom on this example. So let's walk through that real quick. Okay, so if we FOIL out the top, we have 3 times 3, so that's 9. We have, let's just draw an arrow there, 3 times I, so plus 3I. We have negative I times 3, so negative 3I. And then negative I times I is negative I squared. And then on bottom, let's do the same thing. So 7 times 3 is 21. 7 times I is 7I. We have negative I times 3, negative 3I, and then last times last, negative I times I, so negative I squared. Okay, and then let's simplify. So on top, we did multiply the numerator by its conjugate, so the two terms in the middle do in fact add up to 0, and that's a good checking point. They should if you multiply anything by its conjugate. And so on top, we only are left with 9, and then minus I squared, which I'm going to go ahead and jump right into replacing I squared with negative 1. And then on bottom, we have 21. In the middle here, we have like terms. So that's a total of 4I. And then in the back, we have minus I squared, so minus negative 1. Okay, almost there. Okay, on top, 9 plus 1, so 10 on top. On bottom, we have 21 in the front. This is a plus 1 in the back right here. So that's going to be 22 plus 4i. Now this would be the answer. However, we can divide something out. Notice that we have 2 that goes into every term. So we're going to just go ahead and make that look a little better. Divide everything by 2. And so on top we're going to get a 5. On bottom we're going to get 11 plus 2i. 5 over 11 plus 5 over 2. But be careful, I is in the denominator this time. Okay, and that's that one. Let's just take a look right here in this last one just to mention what's going on. So if we rationalize the denominator, just to quickly talk about the two options, you can always multiply when you have a square root, and technically I is a square root. You can always multiply by the same denominator and it will rationalize. So technically I could say 5i over itself. But the other option and the faster one is to just recognize that you're trying to get rid of the radical on bottom, which I represents the radical. So the other way is to just focus on getting rid of the I. So if I multiply just by I, that's going to take care of the problem. So we have on the right side, because that's going to be the easier one, 7i over 5i squared. And then we have 7i on top, 5 times negative 1 on bottom. So this becomes negative, I'll factor that negative out, negative 7i over 5. Okay, and that one is rationalized. There is no more radical or square root of anything, in this case I, in the denominator. The other way, if we had done it here, we would have had to simplify, because on bottom we would have got a 25i squared. On top we would have had a 35i, and then we would have still had to divide out another 5 after we did some work. So this is the faster way, recognizing that we just needed to focus on getting rid of the I. And so we multiplied by another I because of what that represents. It is a square root negative 1. So we times it by itself and it got rid of the radicals and that became negative 1. Okay, so that's it for our operations on complex numbers.